Hi. Our group developed a civil engineering load calculation system designed to support structural design decisions. Our tool computes live loads, reduced live loads, and dead loads following ASCE 7 standards. These are essential values used in structural member sizing and ensuring building safety. The program also supports different occupancy types such as residential, offices, retail, and institutional buildings, each with distinct load requirements. Let's walk through how the system works and how it supports engineering practice. First, let's compute the live load and reduced live load.
This section of the program calculates standardized live loads and reduced live loads for different occupancy type. For example, if we select Calculate Standard Live Load, then select occupancy type, for example, office, enter area, enter floor level, and enter to continue, the calculator automatically retrieves the required live load value and applies the live load reduction formula based on ASCE 7. This applies the same to the reduced live load. This helps engineers design efficiently, knowing that not all areas experience the maximum load at the same time. After live loads, we proceed to the dead load calculation.
For the dead load demo, dead loads represent permanent weights such as the structure itself, flooring, and fixed equipment. Here, we enter the material type and corresponding weight per unit area. The program then computes the dead load instantly. Automating this step reduces potential errors compared to manual calculations and improve design accuracy during the early stages of planning. So here we are about to run the code, then it will allow the user to choose different kinds of materials. In our case, I will about to choose steel. And for the thickness in meters, for example, let's say 10. And for the area, let's say 20. This is only just for example. And the dead load will be 15,401.70 kilonewton. And if you want to choose another, you will just choose whether yes or no. If you said yes, just click Y and enter, then you are about to choose again another material. Let's say wood, thickness 5, area 10. And that's the dead load, 294.30 kilonewton. And if you are about to say no, just click N and enter. And then you finish the program with exit code 0. Thank you.
A key component of the project is the integration of SQLite for project documentation and auditing. This one po. Here in this code, this is a function that handles inserting and calculating result into database using an SQL insert into statement, which is this one. We can also retrieve existing data using select query. For example, when we execute this command in the terminal, previously saved calculations can be viewed and can be checked. This capability helps track design decisions and support modification for deletion when needed. Finally, the system support exporting and reference values into external files.
The project uses a modular Python structure where each calculation type is handled in separate functions. This keeps the code clean, organized, and easier to maintain. Here we use pandas to export reference values into a CSV file. When we execute the export command, a new file is generated that can be opened in spreadsheet software for further documentation or analysis. This improves interoperability with industry tools, making the system useful beyond preliminary calculations. Civil engineering load calculation system, automating accuracy for safer, smarter structural design.